Welcome to Penrose Learning, where we make understanding easy.
You start by verifying your labeled dataset and selecting a Bert-based checkpoint. This matters because tokenization shapes input length and memory. Once done, install transformers, datasets, and torch with CUDA support so training uses the GPU. Next, initialize the tokenizer and dataset loader, mapping raw text to token IDs and attention masks. Make sure to set max length and padding strategy early. Then create train/validation splits and a data loader with an appropriate batch size to begin fine-tuning. Now you build the model and training loop, attach a classification head, and choose cross-entropy or BCE loss depending on labels. Initialize Atom W with weight decay and a learning rate warm-up scheduler to stabilize early steps. Use mixed precision for speed and lower memory, and apply gradient accumulation when batch size is constrained. Then log metrics each epoch, validate frequently, and checkpoint only when validation improves. This helps you iterate quickly and avoid overfitting while keeping reproducibility in mind. To finish, run a final evaluation on the held-out test set and export the trained model with its tokenizer so you can deploy reliably. If you need lower latency, consider quantization or distillation to a smaller student model. Make sure to run inference tests and sanity check predictions. If metrics are worse than expected, try lowering the learning rate, freezing lower layers, augmenting data, or increasing validation frequency. These targeted fixes address common training instabilities quickly.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.